Hi students, welcome to the second part of cohesion coupling. In the previous class, I said about the meaning of cohesion and what are the various types of cohesion. Let me say one line about the cohesion part so that I can come to the present topic of coupling is. The statements exist in a particular module should bind together to achieve a simple task is all about cohesion is. So we should see call when there are many cohesions that exist like functional, sequential, communicational, procedural, temporal, logical, and coincidental. We must see that all the statements in the given module are functionally binded together. That's why the highest priority have been given to the functional cohesion. We should maintain a functional cohesion in any of the modules. Now we move to the this present topic that is called coupling is. When a particular software to be developed, the design aim is called identify the modules as many as possible and should see called the module is the last component in the given project is or the software is. The further decomposition of module should not happen is. So when we have identified the various modules, so how do you know that is called we have maintained a proper way of division is done. The topic is required to be understand is coupling is. The definition of coupling is the degree of dependency such as the amount of interactions among the components. Components or modules, both are same. When you see this particular diagram here now, I have is here now there are various modules you can find it out here. This is one module, second module, third module, fourth module. In these four modules, there are no dependency exist among these modules. Are module 1, module 2, module 3, module 4 you can consider in this example, and four of them are very independent each other. When you see the second diagram, this diagram, what you have is called this is loosely coupled, but there is a dependencies exist. You can see arrow mark here now. This is module 1, module 2, and module 3, and here this is module 4. So these four modules you can see here now dependencies. To run this module here now is called this module. It needs a input from the fourth module. That's why arrow mark have been shown. And run the 4 and it needs to send the output to the 4. And second to run the second and it's dependent on the 1. 1 sends some value to the 2. And 3 is dependent on the 2 and again 2 is also dependent on 3. This type of is called a loosely coupled type of coupling is. And the next one is called highly coupled one is called many dependencies are exist. Here now only some dependencies, but here now you can see arrow mark. These many arrow marks you can see here. This is called highly coupled one. So in this all these three of this type of coupling, which one should be maintained is also important for us. Let's see the types. This is like a arrow mark which I used the same type of arrow mark in the cohesion. Here also we have used the same type of arrow mark. The content coupling, common coupling, external coupling, control coupling, stamp coupling, and data. So in this all this type of the things, what you have is here now content type of coupling should be avoided. That's why we have called symbol called content coupling is. Same time, when you come here now, try to achieve the data type of coupling is. That's what try to achieve. Low, loose, and high coupling is. What is content coupling is one component modifies the other one. One component, what it is here now, it modifies the another component definitely. So component directly modifies another's data. Component modifies another's code. For example, jumps go to into the middle of a routine. So should we have called languages allows this type of feature? Based on this one is called the type of the program. Sometimes the language supports us. For example, C language supports GoTo also. We can go to that one. So GoTo is different from is called calling a particular function is. and goto is a very particular one in the assembly language also. So example is called part of a program handles lookup for customer. When customer not found, component adds customer by directly modifying the contents of the data structure containing customer data is called. This is an example about this one is. Common coupling is called more than one component shared data such as global data structures are usually a poor design choice because lack of clear responsibility for the data reduces readability, difficult to determine all the components that affect a data element, difficult to reuse components, reduces ability to control data access. And this is an example you can see here now. External coupling here now called two components share something externally imposed. External data is external file, device interface, protocols, data format. All these are examples of external coupling is. When you come to here now call the control type of coupling is component passes control parameters to coupled components are maybe either good or bad depending on situation. Bad if parameters indicate completely different behavior. Good if parameters allow factoring and reuse of functionalities. Good example sort that takes a comparison function as an argument is. The sort function is clearly defined, return a list of in sorted order, where the sorted is determined by a parameter. This type of coupling is called control coupling. Stamp coupling is what you have is called component passes a data structure to another component that doesn't have access to the entire structure is. So you're combining all the data and sending as a one particular component to particular component. It's called a example is called structure, union. These type of examples you can take an example in the C language point of view. Requires second component to know how to manipulate the data structure. The second has access to more information that it needs. May be necessary due to efficiency factor. This is a choice made by insightful designer, not lazy programmers. Is. Example is called customer billing system. Is. So these are examples you can see here now in the object-oriented programming point of view. And let's see data coupling, which is the best one to be maintained is. Component passes data, not data structures, to another component is. So every argument is simple argument or data structure in which all elements are used. Good if it can be achieved. Example, customer billing system. The print routine takes the customer name, addresses, and billing information as arguments and does the work is. So uncoupled is also one type of things. Completely uncoupled components are not systems. Systems are made by interacting components. Are. This is an example you can see here now. Data coupling between the pairs of modules. You can see here now. This is one example is said. So overall is called here high coupling and low coupling is high coupling means components are difficult to understand in isolation. Changes in component ripples to another one. Components are difficult to reuse and low coupling may incur performance costs, generally faster to build systems with low coupling. So we should maintain here now the low type of coupling is always to be required. So that's all about these two topics of coupling and cohesion point of view. Any further, if you want to know information, please ask in the discussion chat or you can write in the feedback session. Feedback forms means here in the Google one, in the YouTube, you can write in the comments, you can ask the questions so that it is possible for me to write this one. So all of you, wish you good luck. Thank you very much.